Hi, today I'll be doing something for this week's CodePen challenge that is random stuff. More exactly, I'll be showing you how to uniformly distribute random dots all across the surface of a disk. This second case right here, and how not to fall into the trap that leads to this first result right here. Now, I'll be starting with something a lot simpler, which may be a bit too simple for you, but don't worry, this thing is going to have chapters and you can just skip to the disk part. But in the beginning, I'm going to start with a uniform distribution along a line segment. So let's say that we're going to have something like a heading, so line segment right here, and we're going to have a div. This is going to be the actual distribution, and we're going to have something like this 3 times. But first, let's set a class here. So this is going to be for the segment, and then the other 2 cases that we're going to discuss here, and you're going to see in advance what those are going to be. So we're going to have circle distribution on a circle, not across the surface of the disk, just on this boundary circle, right? A uniform distribution just on the boundary circle. Okay, and let's change the class. Yeah, if I could use a keyboard, that would be great. And finally, this is going to be all across the surface of a rectangle. Okay, now having done this, let's do a bit in terms of layout. It's not going to be much, so just on the body and on all div elements. You may have seen this in my previous videos, just set display grid on everything, because this really simplifies things later on. And here for the divs, we are going to have, every div is going to be a 1-cell grid. So we're going to stack the before and after, one on top of the other. So before and after, they're going to be stacked on that 1 cell at the intersection between the first row and first column. That's going to be grid area, first row, first column. They're both going to have content. Okay, set to nothing. We're going to set background current color, and we're also going to set here align self center, something like that. And now for the after, we are also going to set, let's see, so we're going to have something like a unit, let's say 3 pixels, right? So here we're going to set the padding to that unit, and we're also going to set the border radius 50%, and also justify self, this is going to be start. Actually, I think I'm going to just set this on the div as well. And let's also set here and on the before, actually I think we can just set it here. Let's set color silver, because I already changed it on the after, right? And now for the segment, we are going to start styling the segment distribution case. Now here for the before, we are going to have a segment length. So let's say, I don't know, something like this. It could be pretty much anything. So we are going to set the width to that, segment length, the height to 2 pixels. So we're seeing it now. And then we are going to have a dot distribution using box shadow. Now, this can be done with various techniques. For example, we could have 1 element per dot, but here I don't want to clutter the markup, so I'm going to use box shadows. But that's another valid option, have 1 element per dot and position them using transform. Or we could have SVGs, and there our dots are going to be circle elements, and we are going to randomize the x coordinate of their origin, so Cx, the CX attribute, or we could have canvas. The same technique applies everywhere, regardless of the approach, of what we use to generate, whether we use CSS, whether we use SVG, whether we use Canvas and JS, it doesn't really matter. It's going to be the same mathematical formula. Okay, so let's create our mixin here. Mixin segment distribution. We are going to have a number of dots and then the segment length. Okay, now one more thing I wanted to set here, margin 0 vertically, and also minus that unit horizontally, like that. Okay, and here that does really weird things to, you can see the syntax highlighting. If I just have minus u instead of -1 times u, that's kind of weird, but yeah, it is what it is. So we're going to have a list of box shadows, which is going to be empty initially, and then we're going to have a loop. So for I from 0 all the way up to n, and here we're going to have the list of shadows set to its previous value, and then we're going to add the coordinates of the next shadow that we add. And the first one is going to be the random position, a random position anywhere between 0 and this length, the segment length L. Now let's also create a random function here. Function random, and it's going to have a maximum, a minimum, and also a decimal precision. Now this is going to default to the decimal precision, and the minimum is going to default to 0. And here this is going to return the minimum plus random, and here we're going to have the range, which is the maximum times the minimum times a multiplier. But to get that, we are going to need to import a module. So use SAS. Okay, and here we're going to compute that multiplier. I cannot type. 10 raised to the power of that precision value. Okay, now having done this, we're going to multiply with that multiplier m, and then divide outside the random. And here we are going to have random 1 with the default minimum and precision times the length L. So this basically gives us a random number between 0 and 1 with 2 decimals precision. Okay, and along the y-axis we're not going to vary anything. So then we're going to have box shadow set to that list of shadows. Okay, now having done this, on the after, wait, this is going to be on the after, not on the before. So that margin, I actually wanted it on the after, and include the segment distribution. Let's say we're going to have 100 points, and that segment length, let's see it. And yeah, you can see how now we have a uniform random distribution. And of course it can be with fewer points, so 50 for example. It doesn't really matter. It's a uniform random distribution across this line segment. Okay, now next step, we are going to have a circular distribution. Okay, now for the before, we are not going to have those dimensions. We are going to have a radius here. Let's set it to, I don't know, 8 ems, something like that. Okay, we're going to set the padding to calc that radius plus 1 pixel, and then we're going to have Actually, here let's set on both the before and the after background none. Okay, and here let's also set border radius 50%, so that's round, and set box shadow inset 0 offsets, 0 blur, and then 2 pixels for the shadow. Okay, now here we're not going to have any margin, but we are going to have justify self center, and here we're going to have a circular distribution that is going to use that radius. So let's copy paste the mixin and modify it for the circular case. Now let's get rid of that part, and let's see how we distribute dots around the circle. Now we need to get the position of a point on a circle, and this is defined by a radius, you can see it in pink, and an angle, that one in orange. Now this radius in our case is going to be fixed, right? So the only thing that we're going to vary and where we're going to introduce the randomness is going to be the angle. So the angle is going to be the random part here, okay? And how do you get the x and y coordinates required for the box shadow? Well, you can consider, you can see here we have a rectangle, so all those corner angles are right angles, which means that this side equals this side, opposite sides are equal in a rectangle, and this is the y coordinate, so this is y, this is x, right? This is the hypotenuse in this right triangle with the right angle right there, and we know it to be the radius. We know this angle, so then this edge is going to be the radius times the sine, so this edge is also y, so y is the radius times the sine. This edge is x, and it's the radius times the cosine. So that's how we get those x and y coordinates. And again, the randomness is going to come from the angle. So the current angle is going to be random 360, and if I could type, that would be great. But apparently I can't. Times 1 degree, and then here we're going to have radius times cosine of that current angle. And now we're going to copy paste that, and for the y coordinate we're going to have the sine, and this is going to give us a nice circular distribution, uniform circular distribution. Now next step we are going to have for the rectangle. Actually, let's just again copy paste, and we're going to have a width and a height. So let's say that the width is going to have something like that, the height, I don't know, it doesn't really matter, just some random values there, just so we set something. Okay, and we're also going to set a box shadow. This is going to be for the rectangle. Okay, and also box shadow, 0 offsets, 0 blur, and we're going to use the unit. Okay, now here, no margin, but we're going to have a line self start. Okay, like that. Actually, this is going to be margin -1 times, I cannot type, times the unit along both directions. Okay, like that. Okay, and now we are going to have a different mixin. This is going to be distribution across the rectangle, and it's going to use the width and the height. So that's what we're going to have here. Rectangle, it's going to use the width and height. Okay, now here we are going to have something very similar, except we're going to have a randomness along both directions. So this is going to be the height, like that. And of course we can have more dots there, 250 for example. It doesn't really matter. You can see we have a random uniform distribution across the rectangle. Now for the distribution on the disk. We are basically just going to copy paste this part and then just delete stuff, and we're going to have two cases: the no case, which gives us that cluttering in the middle, and the correct case. Okay, so class no, and also div class yes. Okay, and then we're going to paste here. We are not going to have much, so we're going to have a case for the no, and then a case for the yes. But until we get there, let's see what we need to keep. We are going to get rid of this segment distribution and the rectangular distribution, because a lot of stuff is going to be a lot more similar to the circular one. And then on the body, we are going to set grid gap. I don't know, so we have a bit of space in between those. We are only going to keep the radius and that unit right there. Okay, we are going to collapse that random there. Let's take this, so we are going to get rid of that border radius. Here we're going to have place self. Okay, center. We're going to get rid of that part, and for the before, we're going to have a padding that's going to be calc the radius plus that unit, so like that. And we're also going to have opacity, I don't know, something like 0.25 should do it. Okay, the color, we're going to take it out of there. I think that's pretty much for what we have to do there. Here we're going to have color, and this is going to be something like that. Here we're going to have the no distribution, and going to have it for the after, include no distribution, endpoints, and yeah, that's going to be a radius, right? So something like that. Okay, what's wrong? Yeah, we didn't define an n. So you can see how we have that circular distribution, but we want one across the disk. Now in this case, this means that we also need to vary the radius. So we're also going to introduce randomness for the radius. And the first temptation is to get a current radius that's a random value in between 0 and that maximum radius. So random 1 times the radius, and here we're going to have that current radius, and that's a pretty small number, but let's say we have something like this, and you are going to see a clustering right there in the middle. Now that's not what we need. That is wrong because we get that clustering. So let's also have the correct version. And this is going to be the yes distribution. And okay, too many dots. So let's say we're going to have fewer dots. Let's say the same number. Something like that. Oh, right. This is going to be for the yes. Okay, much better. So let's collapse everything that we don't need, that's not essential right here. So how do we get a proper uniform distribution without that clustering in the middle? Well, one starting point is the following. The surface area of a disk is pi times the square root of the radius. So what we actually want to have here for this current random radius is not a random value between 0 and the radius, is actually the square root of a random value between 0 and the radius squared. Now the thing is, we can get that radius squared out of the square root, and we're left with the square root of this random value. So something like this. And you can see how we now have a uniform distribution. And it becomes a bit more obvious why we're doing this. So we don't really want a random number between 0 and the radius. We want a random value that has fewer chances of being closer to 0 and more chances of being closer to the radius. And if we just take this multiplier in front of the radius, a random number that has fewer chances of being closer to 0 and more chances of being closer to 1. And the thing is, let me just show you on a graph here. So the distance between 0 and 0.1 is the same as the distance between 0.9 and 1. However, the distance between their values, the value right here and the value right here, is a lot bigger than the distance between the value right here for 0.9 and the value right here for 1. So this is how we get a random distribution that's more rarefied towards 0 and denser towards 1. Okay? So this is the result. This is what I wanted to share for today. So I hope you've enjoyed this video, and if you like the work that I've been putting out for about a decade now and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon. The link is going to be in the description. Or if monthly support is not your style, there's the option of a one-time donation. Again, the link is going to be in the description. Or you can make this stray cat happy with a gift of her wish list. The links are going to be in the description, as well as the links for these demos on CodePen. You're going to find them there, and links for all the other resources, again, are going to be found there. Or you could at least share this to show the world what can be done with code and mathematics these days. In any event, thanks for watching, and I'll see you next time. Bye!